last time, like 15 years ago or something. I don't know when that was. Yeah, it was pretty.
Yeah, I've been there too. It's nice. Yeah.
But this time we went to Puchberg, Puchberg de Schneeberg. That's right. It's true. It's a bit of a commitment,
Yeah,
but it's not too expensive though. Well, it was like for the 2 hour train ride, it was just $25 each way though. Each way.
That's not too bad.
Yeah, it's not too bad.
Yeah.
Yeah, it seemed very cheap actually.
Maybe.
Especially, yeah.
Yeah.
Is that right?
Well, I certainly thought the subway here was expensive, like €3 something for one ride on the subway. The U-Bahn, yeah, that's expensive.
That's
Yeah.
what I did for here.
Yeah.
I bought the week thing.
Yeah.
I bought it. Yeah, for in town, I bought the Mobile, VN Mobile, and then the OBB one for the trip to the mountains. And we got to start. It's 9:01,
Oh, okay.
so you're up, and you can click from here.
Yeah.
Is this one? Yeah. So we go.
Click from here. Okay. Welcome to PIM, everyone. Got a nice view this time. If the presentations get too boring, let's see. So the note, well, hopefully you've already seen it this week. It's about how we behave in the IETF. So please make sure you are aware of this. This is our agenda. It's actually a pretty busy agenda, lots of topics. Any comments on this? Any changes? Okay, I'll move on. Then I'll go through the working group status. So basically all our working group drafts. So the very first one, we are about ready to request publication. We're just waiting for IPR and some boring stuff before we can do that. So that's part of our work on moving to IGMP version 3, MLD version 2 as internet standard. This is like the host requirements, which is like 30 years old and doesn't discuss IPv6 or anything. So we were updating that. We got the DR improvement and BDR drafts that are not presented this meeting. Yeah, we'll see how we can make progress on those later. We got 2 new RFCs. That's our point to multi-point work. So that's nice. Yeah, let's see. Got some young drafts that we hopefully can wrap up soon, not discuss this time. Lessons learned we will discuss. Then we got all these group discovery mechanisms that are moving on. We got the gap for requesting publication, it's in last call right now. Then we got 2 that are in RVC editor's queue, and we got 1 more that needs to be revised. So yeah, so that work is wrapping up as well. And then let's see. Yeah, the multipath proxy is not discussed today. We got this PFM forwarding enhancements that is in the ISG. There's some discussions that need to be wrapped up, but yeah, it's moving on. We got the deterministic ECMP. So one slight challenge there is Bill Fenner that brought the work here. He hasn't been available, or I haven't been able to reach him. I'm trying to figure out what to do, if I should just, I'm a core for all the drafts, so maybe I should kind of update it and hope he's okay with the updates. But we need to make progress on that. I think there is good interest in the working group. SRV6 not discussed today, and we are progressing some Lisp attributes to proposed standard in the SPIS draft. That's not presented today, but we will talk about Lisp multicast deployment today, which is kind of why this work, well, some of us think this work should move to proposed standard instead of experimental. And we got the Flex algo that was adopted just before last IETF. So that's what's going on in the working group. Any comments, questions?
Did you mention gap?
No, it was here. So.
Oh, okay, yeah.
So basically, it's an IETF last call right now.
We're just answering questions.
Yeah.
Okay.
One slight challenge with gap maybe is like the address allocations, but we'll see how that goes. At least it's with the ISG right now. Yeah. Okay.
Yeah, very good. Lessons learned. Yeah. Okay. It's kind of not a very convenient place to see the slides. All right, so we've made a fair amount of progress with this draft, which we've been working on for a couple of years now, I think. We thought we were nearing the end, but we received a flurry of comments and suggestions, so we did add quite a lot. 5 new sections towards the end dealing with a lot of different topics. We don't go into a ton of detail. We just add a paragraph or two to kind of share some background and then some basic lessons learned that we've done. The draft has already proven fairly useful just to be able to provide a history to people. So we're not in a big hurry, like I mentioned, but depending upon how many comments we receive between now and the next IETF, we may start thinking about finishing it up. So we did add, aside from a new section, we did add some new text, which is just basically saying that SAP is typically paired with SDP, and added some RFCs per somebody's comments. I can't remember who. The new sections are, this is the first of the 5. This one first deals with socket APIs and scope IDs, just basically saying that multicast app support has depended on OS socket APIs, not just the protocol itself, and the API design itself is a lesson learned. We put in some RFCs to show how standardizing the socket APIs has occurred to allow cross-platform operation. Mentioned the RFC to deal with scoped addresses, introducing the scope ID. Sometimes that scope ID has been inconsistently applied across OSs, and so that's kind of a lesson learned. Textual embedding and higher level libraries have helped. The second new section we added is quality service and data plane considerations. Of course, multicast saves aggregate bandwidth, but it does concentrate replication on certain points in the network. And so each fan out router, it turns one incoming packet into multiple outgoing copies. So there is a replication load that we need to be honest about. And that doesn't always scale linearly with the number of receivers. There are hardware replication limits. Consistent QoS treatment across the copies are important and often an overlooked deployment consideration. The third one was control plane scalability and resilience considerations. Large deployments do stress CPU memory and control plane bandwidth. Reconvergence after a link, RP or topology failure can introduce loss. RPF checks do depend upon the unicast routing table. And so unicast instability can directly affect multicast forwarding. Just things like that, including graceful restart and just documenting how this can affect multicast. Multicast scoping, we didn't have that in before, and that's kind of an important one, and administrative boundaries. So we added, you probably remember how we used TTL-based scoping. IPv4 introduced administrative scope block, and IPv6 did as well. And so we just shared some things like in hindsight, it would have been good to do that from the start, the scoping from the start. Mobility, we're all probably familiar with the bit of the history. I remember we all sharing many drafts, and I think in here and maybe in the whatever that mobility working group was, or maybe still is. But someone suggested we add that, so we added just a little bit about that, some RFCs to talk about the mobile IPv6. And different approaches of tunneling the traffic through mobility anchors. And it did add a fair amount of complexity. So they saw limited deployment, kind of lost track of mobility, in fact. So I'll get to your questions in a second. So these are, we're continuing to make slow and steady progress. Thanks to a lot of people, particularly since the last IETF, Prasad and Ahmed provided a lot of draft review comments. So thank you to them. Prasad, you have a question?
More a comment, Mike. Should we talk a little bit about OAM? I don't know.
Like the history of OAM with multicast.
Yeah.
Yeah, okay. I think we probably should. Stig mentioned, go ahead. Yeah, let's do that. Thanks. That's a good idea. And Stig mentioned to me that maybe we don't have PGM in there right now either. We probably should talk about pretty good multicast in that area. We talked about that yesterday a little bit in the multicast side meeting. Yeah, David?
Developer. It's more of a note to myself to send you some text. I just realized the behavior of multicast on the loopback interface is also something maybe worth documenting because it does notably differ between operating systems, and it is rather annoying to deal with, and probably a lesson learned to not do weird things.
Yeah, good point. Yep. Thank you.
Stig here, couple of comments. Yeah, for the reliable multicast stuff, there's PGM, but there's maybe other mechanisms worth mentioning as well. Do you have PIM port in there? That's another thing.
Don't remember.
Yeah, so, and for mobility, maybe talk about Lisp as well. You mentioned Lisp elsewhere in the document, but that also solves the mobility issue.
That's a good point. Okay.
Or like overlays in general.
Yeah, right. Very good. Thank you. Let's move on.
All right. Yeah, okay.
Are you up?
Yeah. I can find my way out here. All right, so this is something I presented last time as well. And I've hopefully made some improvements to the draft since then. Can you hear me okay? I feel like this is a bit low. Okay. So the basic idea, which sounds a little strange perhaps, is that we want to forward native IPv4 multicast through an IPv6 only core network. So there are people that just for ease of management want to basically do IPv6 only core, but they still do IPv4 unicast and multicast through that core network. And unicast is handled well by 5549 and whatever the 5549 bits is called, but there's no good solution for multicast. And the idea here is you run IPv4 PIM pretty much as usual, except since you don't have IPv6 addresses, you will need to use IPv6 headers when you send PIM messages. And also when you do RPF lookup, you will need to basically find an IPv6 next hop. So it's kind of like usual, but slightly different. So what's new in this version? One is that it's proposing an all PIM routers IPv6 multicast address for use by IPv4 PIM. So, you know, today we have a well-known v4 address, well-known v6 address, and your maybe PIM IPv4 PIM process will listen to the v4 address and IPv6 PIM process to the v6 address. Here I'm proposing a new v6 address that your IPv4 PIM process will listen to. Because it wants to talk to other IPv4 PIM processes. And by doing this, we can have total separation from existing implementations. So there's no risk of accidentally having some router getting a strange message it doesn't know how to handle. I think that was one of the concerns last time. Also, it means we don't need a hello option to see if our neighbor is capable, because a router would only receive these messages if it is capable. Otherwise, it wouldn't listen to this well-known address. And otherwise, the change is all your multicast PIM messages, you know, that are like linked local to your neighbors, they will use this new address with IPv6 headers. That's the only change. But it means that your PIM neighbors have IPv6 addresses, and yeah, your joins, they will contain v4 source and group addresses, because we are building v4 trees. But the upstream neighbor address is a v6 address, because our neighbors are IPv6, have IPv6 addresses. And to be safe, I think it should be like on a given link, you either use this or standard PIM. It's not like you can mix this on a link. That could get into a lot of trouble with not all PIM routers seeing each other and so on. What did not change is, I still think we should keep RP handling out of scope. And a couple of things there. For one thing, it's difficult to solve, but also, well, an RP needs to handle our registers, of course. But if you place the RP outside of your core or give it a v4 address, that takes care of that part. If you think about first up routers, you can only be a first up router for a v4 multicast source if you have an IPv4 address. Else you won't be on the same IP subnet as your source. Or the other way around, those IPv6 core routers, they will never need to send the IPv4 PIM register, because there's no v4 sources. So the only constraint I feel is that you need to give a v4 address to your RP, wherever that might be in the network. If you're doing SSM, this is of course not a problem. So I'm not sure if I should repeat this from last time, but at least the idea is we have these darker blue routers in the middle that are core routers with v6 only, no IPv4 addresses, but we still want v4 multicast to flow through them. And then we have these edge routers that have IPv4 addresses. And if you use RPC 5549 or the successor to that, we will basically have IPv4 RIB that has IPv6 next hops. And we'll use that for RPF lookup. And it will tell us how to go through this IPv6 core. And basically, our IPv6 next hop is where we send the PIM join, just as usual. It's just that it's a v6 address. Yeah. Okay, the last slide talked more about unicast. This is multicast. I think I'll skip this one. I've mentioned all of this already. And our PIM join message looks just like normal, except you see the upstream neighbor address is a v6 address. And that's easy to do with PIM because we have this encoded unicast address that has an address family field. And for unicast, you would need an IPv4 RIB in a core, but if you use RPF vector, we can actually avoid that if we want to. So that means that the only v4 state really in those core routers is the multicast forwarding table that we, of course, need to forward multicast. So yeah, hoping for some feedback. Also, yeah, do you think this is worth doing, and if so, is it ready for adoption?
Yeah. Okay. I guess I'm asking the same question that you just asked, David Lamparter. The benefit, as you point out, is you can get rid of the last IPv4 address on the router, kind of, to get to where you have only one. I don't think we need this, and that is what we need to be asking ourselves here, if it's worth doing the work for. I was much more optimistic about this last meeting. We talked about this. I'm gonna say I'm split on this right now. I'm not particularly in favor. I'm not particularly against this. It is a whole bunch of work to get rid of that one last address, and yeah, that's it basically.
Yeah, when you talk about that last address, you can kind of do it if you have one IPv4 address, but it needs to use like unnumbered with all the same address on all your interfaces, and yeah, anyway. Yeah. But yeah, it's motivated basically by customers that say, we don't want v4 in our network. Any more comments? So, but yeah, talking about code changes, so I have implemented this. Sending packets over v6 instead of v4 is pretty easy. The main code change for me that took some effort was the handling of IPv6 PIM neighbors and RPF lookup with v6 for a v4 process.
Right. As you asked for feedback, we discussed this yesterday in a separate round. And I think the ask of the customers that you mentioned is valid. I also would see some use cases where we are thinking over this solution in parts of our network.
Sorry, what was the last you said? In what network?
Parts of our network.
Oh, yeah.
Right.
Yeah, thanks.
Oh, sorry for the protocol, Nils Deutsche Telekom.
Yeah, thanks. Yeah, I can also add that there are lots of networks doing this for unicast today, and that works. But if you do multicast, you need something like this. Yeah.
So yeah, well, I'll go ahead and ask on the list if opinions about adoption. It looks like there's a handful of people that think it's ready. Is that fair enough?
Yeah, sure.
Okay.
Sounds good. Thanks. We'll be happy for more comments or input later.
Yeah, he's on.
Hello, everyone. I'm Yisung Liu from China Mobile. I will present this PIM RPF vector conflict resolution on behalf of my co-authors. This draft specified to handle the case where one join message can include the RPF vector, while another that does not. So that's a simple scenario. So this draft was firstly presented in the IETF 123. So the mainly updates from the last IETF to now is that the first one is that we have added new courses, Gallum and the McManus, and we have added the one scenario for the scenario 2, inter-area multicast FR, and for the conflict handling rules for the scenario 2. And then we also address the comments from Stick. Thanks for the Stick, and update the we clarify that we update the RFC 5496 and the RFC 7891. By the supplementing the existing specifications with handling rules for these specific conflict scenarios. Next I will give some introduction for the two scenarios. Firstly is the partial RPF vector. And in this figure, we can see that for the R1, for the receiver R1, the primary join, like in the red line in the figure. And from R4, R3, R2 to R1. And the backup join, like the blue one, blue line in the fig. And so in the R6, for the blue line, we can create the entry incoming interface for the F1, and for the outgoing interface for the F2. But for the R2, it only had the primary join, and like the green line in this fig. For the same R6, for the incoming interface is if2, and the outgoing interface is if3. So that's a confliction in this scenario. The scenario 2 is for the inter-area multicast FR. So for the inter-area multicast, we should carry the IP vector. So for the R2, we can only have the primary join, and we can only contain one vector for the ABR. That in the R6, we have the entry 2 that the like the green line in this fig. That's in the R6, we have the incoming interface is if2, and the outgoing interface is if3. And for the R1, it had the backup join. The backup join, like the blue line in this fig, and it will take the two artifact vector R5 and the ABR. So it will in the R6, it's the incoming interface is if1 and the outgoing interface is if2. So there's a confliction in this scenario. So summarize that the problem statement as that when the RFC 5384, when the join messages with the same attributes types, so prioritizes the neighbor address selection, and if the address are the same selected by the interface index, and for the RFC 7891, and then when PIM join message with join attributes is received, the router must verify the consistent order of the IP vector types. If the order is consistent, the types are ordered considered equal. Selection is made according to the RFC 5384. So neither of these RFCs specify how to handle the case we have mentioned in previous slides. So here we give some recommended handling mechanisms. So when the two conflicting join messages are received, firstly, if one with the IP vector and the other without, the join message without the IP vector is given the priority. The second one is that if one join message only contains a type 0 IP vector, and the other contains a type 4. Type 4 means the explicit RPF vector. So the join message with only the type 0 vector is given the priority. The third one is that if one join only contains a single type 0 RPF vector, and the other contains a stack of the multiple type 0 RPF vectors, so the join message with a fewer artifact vector give the priority. So in the previous scenario, we can get these results for the scenario 1. The recommended handling process in this fig that for the R3, we can get the incoming interface is the if1 and the outgoing interface is the if2 and the if3. So the backup from the R1 will be blocked. And so in the R6, we have the incoming interface is if2 and the outgoing interface is if3. And for the scenario 2, the backup join from the R1 was blocked in the R6. So for the R2, we have the entry incoming interface is if1 and the outgoing interface is if2 and if3. And for the R6, we have the incoming interface is if2 and the outgoing interface is if3. Only the primary join from R2 existing. Yeah. So that's all. Welcome more questions and comments, and we co-authors think that the draft is ready for the working adoption. Thank you.
Yes, Stig here. One question. So I'm wondering if this is backwards compatible with the RFC 5384, I think, the original join attribute RFC. So one thing it says there is that if two routers send the same attribute, the one with the highest IP address, I think, is the winner. But here you are saying that the one with the shortest list is the winner. So I think maybe old implementations, they may look at just the first attribute and see which one has the highest IP address. But now they should look at the length of the list.
Yeah, but because the fewer the fewer RPO vectors means that yeah. We want to assure that the basic PIM join function would be assured.
Yeah.
So that's we make the fewer is.
No, sorry. Yeah, let me just add. So I agree. It seems like the best behavior. My only slight concern is if some router implements the all RFC and another router implements this improvement, they might maybe make different choices.
Mankamna Cisco systems. So do you think making that this RFC updates the previous one make more sense?
Yeah, I think this maybe should update that, but you might maybe also need a hello option or something to indicate that you support these new rules. I'm slightly worried otherwise that even if you say the RFC updates it, there will be implementations that only use the old rules.
Sure.
Okay, thank you. There's no more questions. We'll ask this question on the list.
Thank you.
We did have a poll. There was one person in that was ready. So otherwise people don't have an opinion. Thank you, Yusong. Yeah, Louise, you're up. Yeah, let me find it.
Hello everyone, this is Luis from Telefonica. I will present this new version of this proposition for having a way of signaling echo mode using IEMP MLD extensions. I will do on behalf of Marisol and Benjamin that recently joined the draft. So just summarizing a little bit the rationale here, the idea is to enable the capability for the end users, for the listeners, to signal the willingness of having a more eco-efficient or energy efficient delivery of the content. But this basically could apply, of course, to the resolution, for instance, of the video streaming that is being received, but also from this signaling, other actions could be derived. Maybe optimizing the energy consuming in the path, or maybe from the devices even to take decisions, maybe going switch off and whatever. The draft does not enter on what would be the actions being triggered by the signaling, but simply proposes the way of signaling these capabilities so that later on some actions could be triggered as set for optimizing the energy consumption in the overall delivery of the streaming. So for that, well, we are leveraging, sorry, I forgot to mention on the extensions that allow, that were defined in, I don't remember now the RFC number, I think it's later in the slide, but these TLBs that can be added to the AGMP MLD messages for extensions of them. So from 00 to 01, apart from having Marisol and Benjamin as co-authors, we have improved the description of the problem statement. So going further into the details of what would be the advantages of having this kind of signaling. We have added a relationship with the energy efficient network management capabilities in broad terms. So you know well, there is this other working group, Green, that is working on this management of energy efficient management of the network. So basically we provide some hints there. We have also added some description about use cases, and I'm going very quick through them. Large scale energy aware multicast distribution, where basically this eco mode preferences could help to select the delivery alternatives. So basically the proper resolution of the video streaming. Energy aware multicast video streaming, so basically selecting the more efficient path. Mobile multicast environments where maybe the battery of the terminals could be benefited as well of enabling this capability of signaling more efficient delivery mode. Carbon aware multicast delivery. This is going a little bit a step beyond the energy efficiency. So taking into account the energy mix that is feeding the power of the central offices, and so probably a little bit more futuristic, and somehow also exploring the possibility of having ways of incentivizing users for doing more responsible from the point of view of energy consumption. Yesterday, during the media operations working group, also there were some other interesting things that maybe could be taken into account. For instance, the distance from the people watching the TV, the size of the screen regarding the resolution. So also somehow these kind of scenarios could be taken into account for enabling the signaling of preferences in terms of energy consumption. So we also, in this new version, we have refined the proposition of the TLB extension. I will go quickly through that in the next slides. And we have proposed some metrics. I will also cover them very quick. Regarding the TLB, the RFC that we are leveraging on is the 9279. This RFC defines the possibility of extending the messages for including additional information. So we are, as I said, leveraging on that for defining this TLB. So this echo mode is intended to be supported in both query and report messages. So from the listener to the network, from the network to the listener. And essentially what we are proposing in this new version, we have refined a little bit the TLB, the original TLB. We are adding two fields, the echo level and the preference. I will cover in the next slides. So for the echo mode, for the echo level, we are initially identifying 4 modes. The no echo mode, that would be basically the conventional delivery of the video streaming, so no action, basically. So it would be somehow it would guarantee somehow the backward compatibility with whatever we have now. The light echo mode, where basically the energy saving actions are acceptable if service impact is negligible. So basically guaranteeing that the quality of the video streaming is not impacted. Moderated echo mode, where basically the listener has its own optimization. Even there could be some basically playing with alternatives for delivering the video. And then a more aggressive echo mode, where even the quality could be impacted. So the listener express the fact that it's okay with even if there is some impact on the quality of the video streaming being received. Regarding the preference field, we have proposing for values, let's say, targeting the energy efficiency, targeting the carbon awareness, targeting the renewable energy preference, so basically leveraging on renewable sources, and some other open thing that would be the operator defined criteria that basically would be on the hands of the operator. You see the caution symbol in the slide because these values are basically initial ideas, of course, open for being discussed, and any suggestion is any suggestion is more than welcome, basically. Then regarding metrics, well, there is a question. I don't know. Okay. So we also propose some metrics. Again, the caution symbol is just to signal that these are initial propositions, so open to any suggestion, any discussion, any feedback. So we are considering having some metrics for counting the receivers that are in this mode. Also, having an understanding what is the distribution of the listeners in the network requesting this. Also for accounting the energy or the carbon that has been avoided due to the action of the customers requesting this eco-mode way of delivering the streaming, and basically also the result of the policy has been accepted, ignored, downgraded, etc. So going now to the final slide. So essentially, summarizing, with this mode, we basically trying to enable a way of for the customer to signal the willingness of having a more efficient delivery of the content. This could trigger several actions, not only in the network but also in the devices, in the set-top box, in the TV, and so. But we are not entering in that space. It's just simply defining the enabler for that. And just to comment that the document was also presented in green this week. One of our ideas is trying to set the link with the green management capabilities so that this kind of signal could be leveraged for the green framework at the end, for maybe even collecting metrics, even taking decisions, and so on so far. And we will keep working on that, preparing a new version for next IETF, and basically for today is to ask if this makes sense for the working group to keep working on it. Thank you.
Mankamna Misra, Cisco Systems. So the way I'm understanding, the receiver wants to join some eco mode. But if you look at multicast, so you have host who are receivers, then you have source. So source is going to send different content for different eco mode. How are we translating this all the way to whether overlay join or PIM join, any of those L3? Because you have to connect it end to end.
Yes.
Will it not make more sense to have different eco mode being a different group itself?
Could make sense, probably. So some point here would be that maybe depending on the volume of customers requesting one this eco mode for one group or whatever, to somehow adapt the multicast tree to that to the number of customers requesting this eco mode. I guess that also we need to take into account the resolution of the terminal, and so probably there would be this association in the terms that as long as we are collecting the willingness of the different users, we can even let's say not extend the multicast tree up to the very end if there are no customers requesting that resolution or without the willingness of requesting that resolution at that particular point. So basically adapting the tree to the willingness of the different users spreading the network to the resolution that they want. That could be an impact, a result.
Yeah, so the reason for this question with respect to adoption, so I have seen, so this requires a change in the host application itself, which is, let's say, for IPTV set-top boxes. So doing any migration or upgrade to set-top boxes is relatively harder compared to coming up with new groups. So if you just push that instead of these 100 groups, now you can pick out of 1,000, that is much easier compared to you say that you have to upgrade the IGMP protocol stack. So my comment is related to the adoption of this whole work in the real field.
Okay, thanks for the comment. I think on that.
One more comment. So if you need to basically have different content, like different rate or something based on the mode, then the source needs to know about it. So I can agree with Mankamna on that. But one thing is, I guess other ways you can have eco mode is by using certain links in a network, like not necessarily doing the shortest path or something, right? And then it's something the source is not really aware of. So then the routers need to know whether it's eco mode or not. You could possibly configure statically at the last hop that, okay, this router knows that this group is eco mode. But it's kind of nice to make it dynamic. But I agree, it's a challenge upgrading set-top boxes and so on.
Okay, we will think on that maybe, to see how we can leverage on this for doing something that will be less impactful for the setup process.
By the way, there is some very old expired draft that talks about using some IGMP MLD signaling towards the source itself, so the source can know if there are receivers in the network or not. If you had something like that, you could actually signal from the first router up to the source also and say eco mode is requested.
Okay.
So that could allow the source to do some changes based on this mode.
Thanks for the pointer. I will look for that. Thank you. Thank you.
Are you leaning towards requesting adoption here or in green?
The adoption games, I think, will be here, not in green. Green basically can use this for triggering other purposes, but I think this will be the protocol wise to be handled here.
Are you ready for that adoption call to be made or not?
I'm not sure if it's so soon. Maybe we need to address the comments that Stig and Marakama mentioned and probably come with a more solid thing for the next time. Thank you.
Perfect.
Okay. Thank you.
Yeah, David.
Hello, I'm Ikwi. This is the second time this is being presented here. First time was on Monday in Sixman. This is for a new scope for IPv6 multicast addresses that behave a little bit differently. Right. I guess this is not super useful here to talk about updates. I'm bringing this here to make all of you aware, to get some input from the PIM working group on this. And there's also very notably completely left open right now in the document how it should behave for MLD. And yeah, let's just go into it. You're probably all aware of these special purpose Ethernet multicast addresses that have behavior specified by 802.1q, especially the first one here on the slide, the 180C2 whatever 0E address is the LDP address, and that one is never forwarded by an Ethernet switch. You can find all of these in the 802.1q spec. These three ones here on the slide are special in that they don't have special in that they don't have protocol behavior attached from IEEE 802. And I'm looking at this because there's been multiple drafts in other working groups at the IETF that were looking at using LLDP as a discovery protocol. And the main benefit that you get with LLDP over any other discovery protocol is that you can rely on the fact that it never goes across a switch. And I would like to point out this also means that it never goes into a VXLAN overlay or something like that. So if you want to do some signaling between a host and a top of rack switch that is putting everything into VXLAN that you're also doing with the host, then using these groups is also useful to do something that does not go into your whole overlay network. Rather than having to go to LDP to do all of this, especially if it's routing information, and I'm gonna note the middle of these drafts that does just plain routing over LDP. I rather do have an IPv6 option to do that than be forced into to integrate the layers like that. The TLDR version of what this draft does is these three IPv6 multicast addresses get mapped to these three Ethernet addresses. The draft specifies a generic mapping. It's not these three specific addresses, but these three addresses are the ones that make sense and that are relevant here. That's the thing really I'm trying to get to. It's an update to RFC 2464, which is the original specification that says how you put IPv6 multicast on Ethernet. You probably all know the 3333 prefix, and this is an extension essentially to the rule given there, which is that the very simple rule that you just use the last 4 bytes and put the 33 in front. And this says, okay, and for these special groups, you do this different thing. Yeah, it's a new range at the top level of the IPv6 multicast address registry. The bit combination is currently undefined. It just makes no sense. So this is using a new top level multicast space, I guess. It does put a registry for the layer 2 types to use with this, because even though right now the document only speaks about Ethernet, at some point there might be another link layer technology that has completely different groups specified that have completely different behavior, and those will have different addresses in this out of necessity. So it's leaving room. There's only Ethernet right now. I mean, we all know that Ethernet is 99% at this point, so that's the main thing. And then to go with that, it just specifies the mapping rule for these addresses, so you get the special purpose Ethernet multicast groups. Yeah, this is the table from 802.1q with the 3 groups that I'm highlighting here. I do want to point out some details. This can only ever be less than the entire IPv6 link, because if it were somehow more, that would be the link for v6. It just makes no sense by definition, I guess. I want to be very clear that this doesn't change behavior of these groups in any way. This is only exposing existing behavior. And I'm noting these 3 groups specifically because they are not specified for use with exactly one 802 protocol. They are defined as general behavior of Ethernet bridges, switches, and the document tries to be reasonable in not treading on the IEEE's scope here, and say that you should think about what you're doing and maybe not use some other group that 802 is using for something specific. This does also kind of define how this relates to the IEEE. This is IPv6 making use of an existing thing. It will get a liaison statement if it goes forward, and we'll hopefully get some input there if we need it. It is relatively simple as an idea, and yeah. The main open question here is what hosts should do for MLD on this. It just says nothing about this right now in the document. It's just left as a to-do. As I've already said, the forwarding behavior for these groups is completely out, like changing anything there is completely out of the question, and that must be absolutely clear. This exposes what would happen with these Ethernet multicast groups by default, and nothing should affect that. I'm a little bit concerned that on some devices, if they implement MLD snooping, they might additionally restrict behavior for these groups only for v6 packets, and or I really hope they don't. They might, in the very worst case, affect behavior for these groups. The only thing that can be done for that is just to put in a draft that you're not supposed to do that. My best estimate of what the thing to do here is what I've put at the bottom here. Hosts may send reports. They're not required to. They are not required not to. There's no point in querying. This is not going to be routable in any case. And since snooping makes no sense, the whole query is essentially pointless. And I do think it should have the must not on doing snooping on these groups, and especially on changing behavior for them. That's the main thing I'm hoping for input for at this point. Yeah. Lastly, yeah, the idea is truly trivial. I implemented this during the hackathon in a few hours. It's 31 lines of code to get into the Linux kernel. If you're interested in more details about why the IETF 124 6-man presentation has a bit more on that, And I think that's it. Any questions? Not everyone at once. Well,
Thanks for presenting here.
Thank you.
Yeah, thanks for your time. Yeah, we're doing fine. All right, Prasad. Is that right? Yeah.
Hello,
Yeah.
am I
we can hear
audible?
you. We can hear you. Yep.
Okay. So, good morning. Hello, everyone. Yeah, today I will be presenting the observations tied to the draft Lisp multicast deployment. Yeah, rather than working through the document, I'd like to share from the operation perspective, so what we have actually seen running IPv4 Lisp multicast in the production during the large-scale network infrastructure rollout in our environment. So yeah, and I suspect that operator input here is relatively rare in this working group. So just consider this as field report, and I will stay at the protocol level throughout. So next slide, please. Okay, so yeah, the deployment context involves multiple Lisp sites grouped into the campus. So like campus A and B here on the diagram. So they are connected through an IP underlay with a Lisp overlay on top. And two things worth mentioning. First, we run both layer 2 boom forwarding and the layer 3 routed multicast side by side. So with both ASM, so any source multicast and source specific multicast in active use. And second, the underlay itself does only native multicast. So we are not doing any head-end replication anywhere. So it means the combination of a native multicast underlay carrying out both layer 3 and layer 2 overlay traffic. So it's the background for everything. So I will talk about. So next slide, please. Yeah, let me start with some good news now. Yeah, so first, so during the receiver's PIM join event, so encapsulating the PIM inside a unicast Lisp packet towards the upstream hops, so proved to be a simple and reliable mechanism. And second, the PIM join attributes also give the receiver egress tuner router an effective way to signal the underlay transport information. So back to the ingress tuner router. So it's how the overlay is signaling works here. And third one, choice has been made to collapse the underlay done to the source specific only multicast only for overlay layer 3 multicast. So this also reduced the control plane complexity. The fourth would be the RP placement. So we have a stock with a static RP and anycast RP and MSDP. So not flashy, but a stable well-known combination. So for years. And finally, this would be a more of an operational point than a protocol point. So pushing underlay and overlay configuration purely through an orchestration tools has prevented from human errors. That's very important for the operation. And next slide, please. So here I would like to zoom in on two specific design choices. The first one is what we call n equal to 1 underlay group mapping for boom traffic. Concretely, it means many layer 2 Lisp layer 2 instances. So let's say m of them. So all mapped down to a single underlay multicast group. So this is simple to run, but trade-off is less traffic separation. So all these, so it means all these layer 2 instances share one single underlay group, and every egress tuner router CC boom traffic that so probably not necessarily target for themselves and has to filter it locally. And then the second one is the overlay to underlay group mapping across the sites. This is strictly required to prevent multicast loops when traffic across Lisp sites. And this operation requirement that come with it is that the mapping has to stay consistent across every single devices in the Lisp domain. So when one of it get a run configured, and you can end up either a loop or even silent traffic loads. So next slide, please. So yeah, here brings me to where things get harder. So the first one is troubleshooting. Because the state spans now 2 distinct layers, so overlay and multicast overlays. So considering that many operators already have much less experience with multicast routing than unicast routing, and this dramatically raised the bar for the network engineers. So in practice, only a very small number of people in the team can actually reason about both layers at once and correlate what they have seen. And it's in some scenarios, it's very difficult to have a full picture of what went wrong. And this also loops back to the previous slide that because both layer needs to be configured together, the deployment ends up heavily dependent on automation. And second one is the specific concrete issue we encountered in this push to talk style scenario, where every new core initiated allocates a new multicast group. We also observed that that the drawing simply hasn't converged yet by the time the source started sending, which leads to the receiver missing the core entirely. So this is the real gap I'd like so working groups input on. So maybe is there any recommended protocol pattern, or perhaps a faster drawing signaling, or any other mechanism to avoid this drawing latency loss for short-lived sessions? It could be enhancement or improvement to the protocol. So so to wrap up, Lisp multicast holds well in production, but this 2-layer troubleshooting and short-lived session convergence so remain very challenging. I also suspect we are not the only operators who have hit these ages. And and that's all from my side. Thank you. So welcome for any questions.
Thank you, Junie. So this is something that I'm assuming also presented in Lisp, and you're probably going to seek adoption in Lisp. Is that correct?
Yeah.
Okay. Got any questions for him? No. Okay. Thank you. Thank you for your time.
Yeah.
No more questions. All right, so this and the next draft are spillover from a multicast for AI side meeting that we had yesterday, and we've had 3 of them now. If you're not familiar with this side meeting, it should be something that you should look into. It the meeting was recorded, and it's kind of a big deal because there's a decent chance, in my opinion, that it will become a working group, and it has some pretty wide ramifications for AI in general. So, and the PIM working group should be agnostic to what's solutions are and the different proposals. So that's why we decided to present them here. If it ever does become a working group, then it would be likely being dealt with there, but we would need to have this group and beer and other working groups opinions as well. So just kind of a quick overview if this is new to you. So the predominant traffic pattern within AI is point to multipoint. So whether that's in training or at inference, when you're asking actually a question to a model on Claude or whatever, the traffic pattern is point to multipoint. And that's being handled today by Unicast. And so the reason that we have had these side meetings is that we feel it would be much more efficient to use multicast for these point to multipoint traffic patterns, especially as the scale increases to, starting to use, tens to hundreds of thousands of GPUs that are having this traffic pattern. And so, just to help you understand how it works, like at inference, when you're asking a question, let's say you asked a question that was like 20 words, and that would be converted into like it's like 2/3 of a token. So I think it's like anyway. So let's say that that's converted into a certain amount of tokens, whether that's 30 tokens, whatever. Each of those tokens for each user is sent to a different expert if you're using mixture of experts. And if you have millions of users asking these questions, then that's a lot of point to multipoint traffic. And so that's the purpose of why this side meeting is happening. So these questions have been asked during the side meeting is, what do we do? Do we use an existing solution, whether it's PIM or beer, or create a new protocol that's specific to AI to be able to handle that? And so these are kind of the questions, and the purpose of this particular draft is to evaluate these different solutions. Even some other ones came up yesterday. Is like, maybe we can use some new lightweight method. Maybe we can use PGM to do something like this. There's a lot of different options. In some scenarios within AI, you can, that are stable, that are going to all recipients. Like if there's a situation where all the GPUs have to respond with their correction slips, so they're called gradients, they need to be sent somewhere, then you could use PIM to do that, because it's not dynamically changing for every token. Or if you're distributing on a model to certain locations, and those locations are static, then you can use something like PIM to do that. But for the most part, in dynamic scenarios, you got to use something else. And beer is the leading candidate, because there's no state. You just put in the recipients into the packet, and it goes to where it needs to go. So I've kind of discussed this, just little hand wavy here, but that's kind of sets the stage of why we are discussing that. And in my opinion, it's fascinating. It's something that we'll probably be working on for some time. And it will eventually probably take a lot of coordination with other standards bodies, I'm going to guess. It was brought up that the Ultra Ethernet Consortium is also working on these kind of things. We do our thing here for, protocols, layer 3 protocols primarily. But there will need to be some coordination with other standards bodies as well, if we do wind up doing this. I think I mentioned training collectives. They, as I mentioned, do have stable membership. So there, there's different things that we can do with existing protocols and maybe creating some new ones as well. Let's see if there's anything that's missed here. Yeah, we'll just keep going here. So let me just make one comment here. So InfiniBand is what's used today for the solution to have AI work. And there is this baseline transport header, BTH. And so if we need to have this, new solutions be compatible with InfiniBand, then we would need to likely include the BTH in our solution. So today what we could do is put that BTH in a beer header and just forward that as well. So that would be a good candidate for that. Let's see. Congestion control is an important aspect of this. Scalability, as I mentioned, as that continues to grow, that's why we, there's a lot of need for trying to make this more efficient. So this is kind of where the interesting part is, and again, what I alluded to at the beginning is that do we extend an existing protocol like beer for this mixture of experts where you have which is the predominant traffic pattern where instead of using the entire model to answer a question or to do the training, you just select, maybe 10 experts to handle it. But again, those experts are chosen per token. So it's just a lot of this from one GPU to these 10 other GPUs, and then it changes for every other one. So any question you ever ask, it's typically always using this MOE pattern. So do we extend beer to be able to support MOE? And there are drafts that have been presented in beer and elsewhere to support that. So there's arguments for doing that. It's an existing standard. It's multi-vendor implementation, faster path to deployment. It doesn't, changing which receivers get a packet doesn't require any control plane signaling. Unlike the tree-based mechanisms, it's well suited to dynamic membership, like MOE, like I just described, and the header is payload agnostic, and it can carry that BTH, as I mentioned before, without modifications. One of the big points with this is a drawback to all the different multicast protocols is that there's no native ACK aggregation. So you have to have an acknowledgement in AI traffic patterns, like I mentioned before. We need to see the gradients or the correction slips and then you send out the correction to all the different participants in the model, and then they update their weights. And so that's something that's important. And so there have been some proposals to be able to add ACK aggregation to beer particularly. The bit string size limit, there is a limitation there. There is complexity when you start using hierarchical domains. There's no defined congestion control interaction. And so these are the kind of things that we're trying to weigh in whether we try to extend an existing protocol or do we create something new. So, there's arguments for creating a new protocol. And again, this is very early stage. And if this multicast for AI does become a working group, we would probably need to be able to have some clear deliverables of justifying having a new protocol. Because if there's something that, if we decide to just extend an existing protocol like beer, then that would just be handled in the beer working group. There wouldn't be a need, I don't think, to have a new working group. So you could have a purpose-built new protocol for ACK aggregation for this BTH, RDMA over Converge Ethernet or BTH compatibility, the congestion control. AI data center is a distinct unique group, and this new protocol could be targeted for that use case. And it could enable co-design interworking points. So, do you do the aggregation at the source Tor or some other places? You could define a protocol to be able to handle those certain areas. But there are limitations. Of course, whenever you have a new protocol, it does require new implementations across ASICs and all that. It needs a new working group charter. Operators, it would take a while for them to ever deploy it, and risk potential vendor fragmentation. So we try to do a comparative analysis in this draft. It's early stages and we're continuing to develop it. But ACK aggregation is important. Interactivity is poor for all the existing multicast protocols. Interactivity meaning, the acknowledgements coming back, particularly because we have one-way trees. There's not a return path, even though there are some proposals. Bidirectional PIM, which a lot of us have not even discussed for many years. That's something that's come up as a bidirectional tree topology, but there's no reduction capabilities that AI needs to reduce all these acknowledgements to come in and then forward it on. Highly dynamic group membership requires fast, lightweight group formation, not long-lived tree setup. And so adding stateful per group ACK aggregation to beer could abandon that stateless design. These are some of the things that we have in there. There's some open issues like ACK aggregation, BTH classification, interaction with packet spraying and things like that. So, and I think we have time, but so it would be interesting to get our opinions here in this working group as to, where should we go with this? And it's a little bit of a moot point because, again, we have these side meetings and that's where the bulk of this is going to happen. But we just need to get your feedback, get your ideas of where we should go. There's no existing working group handling this, but it could very well become a working group. We're well aware to handle certain things, certain proposals. We are chartered for multicast protocol development. We could, if needed in the upcoming year, add AI language to our charter if we need to. We definitely need to scope it because, anything beer related would need to go to the beer working group. Anything routing control plane would need to go to other working groups as well. So the floor is open.
Yeah, Thomas Eckert. So the ACK aggregation, that's kind of the biggest unknown for us. I was trying in the side meeting already explaining that there has been a whole empire around that, reliable multicast transport 20 years ago now. The conclusion there was actually that you're doing NAC implosion. It's what they called it. So you send NACs and you then reduce them, right? So they actually call it implosion. But I would kind of, just to keep life simple for us, go with the assumption that this is not needed and the application people first have to prove that it's needed because it's typically needed when you have a large number of recipients, not if you have 10 or so, right? So if we're talking about millions of small groups, I would be very surprised if we actually need it, right? So that's one of the things we really need to get out of the people on the application side to see the patterns, what to do. If you just send 10 NACs back, that's not an issue, I think, right? So hopefully we can avoid having to do that. But there's definitely a question: what would be the best reliable multicast transport to put, kind of in terms of the retransmission and so on, right? There is no such protocol for multicast right now. And I don't think that the unicast protocols like what InfiniBand and others are doing are well suited. It's true that on the Ultra Ethernet Consortium, they're probably having to solve the same problem. So we are going to have solution-wise to look into the reliable transport aspect, but hopefully not on the routers, right? So I think that's my hope, right? Because we've been around the block, we've implemented that NAC implosion, and we know how difficult that is. Going back to the network layer. So first of all, the stateless, more scalable than kind of, what I call now flat bit string, as Beer does it. We presented the first draft with a prototype implementation in Huawei in 2022 in the beer working group. Since then, we've done different variations of that, also built for a variation a P4 Tofino implementation together with University of Tübingen. So there are existing implementations and approaches to do this. So it would be very good from the proponents of these application spaces to take a look in there and say what they don't like about them, what may be needed to be improved, right? So we didn't progress with the standardization request for that because, again, we wanted to see more interest in this. But again, this is not a technology-free zone that we're entering, right? So there is existing work on that. With respect to which working group it fits in and so on, or whether it's a new protocol, let's say this in segment routing for IPv6, a simple list was replaced with a very complex structures, and they just called it compression, and they kept it in the same header that they created in the first place because they liked the header. Maybe in our case it's the opposite, right? It's not about arguing about the kind of structure as opposed to a flat bit string, but that the beer working group had done a very limited, view of what encapsulations for the header are feasible for all the different networks with just beer in 6, right? So I think that's one of the things people with an IPv6 network have been struggling with, and I think that would be lovely to be more amenable to different network requirements. But when it comes to such a stateless structure as opposed to flat bit string, I think the first thing really is, again, we need to have from the side effort a better write-up of the exact scale of the use cases, right? For example, there were very nice proposals, I'm not sure if they were adopted in beer, of just using different subdomains to scale up to the maximum size that we can already do with beer, right? So we should be able to show, you can go this way in this use case with beer, but we need to go beyond it. Or no, we don't, right? So I think that's the due diligence that we need to do. And I think I'd first concentrate on the technical due diligence on these aspects, and I'm happy to help with that on the mailing list, and then the process things, which working group and so on. I'll leave that to people with more administrative knowledge than me.
Sure, and that'll take care of itself probably. Thank you. Good comments.
There was a tall guy on the mic. Hey, so Tony P, HP Juniper. Thanks. Very balanced view of the world. Some interesting new information, right? Where these AI guys are driving multicast. First, 2 technical corrections. So beer is bidirectional, the tree kind of thingy, right? So it's not a unidirectional. The other one is that we have 65K receivers, but we have subdomains. So you could stretch it to a couple 100K, right? You talk millions, the game starts to become difficult, right? So, but that's just mild technical, aspect. I think the layering is a little bit muddled for my taste. I think you point out certain things where the header would have to be modified, so congestion control, right? You don't want to push it behind the header. That's really like a header issue. The ECK game, I would argue you don't want to push the stuff into the header because you fought the PFE update stuff, right? Which is the classical reliable multicast problems. You have no choice. And it depends very much what the design space is. And very often you end up with things like negative ACK designs and things like that, right? So you design a specific ACK thing, compression, and it may not work at all, right? Or you end up with 700 flavors. So I think that's something that goes behind the header and becomes this thing that runs on top, right? And somehow delivers reliability in the desired reliability. I think the in-network computation is exactly the same bucket, right? That's probably not something you want to push into the header. It can go behind. So I think that's the layering thing. And if you look at this ACK implosion flavor, for example, the OAM, which we're checking for beer, right? As the beer ping has the same kind of problems, right? And every time the flavor is different. There's other interesting problem. For example, beer looks pretty cool because every time you can address someone else, It turns out that depending whom you address, your replication will be pretty crappy because the replication points are sometimes a very good idea, right? The receivers are at the very end, the last replication guy, so you save a lot of volume. But if the replication point for all the receivers are all over the place, you end up almost with unicast replication if the replication points are very close to the source, right? And those are problems that also needs to be chatted through for the whole thing to work well, right? So there's more stuff, but I think what you throw up there is excellent. It's very, very well balanced. It's a good gathering point because the side meetings are, to put it politely, stream of consciousness. To put it a little negatively, just a zoo, right? I mean, how do you record and compile it without something like that? So yeah, thanks. I mean, like, push in this direction and see what comes out of there. Yeah, thanks.
Yeah, thank you. We're
Thanks,
trying.
Mike.
Yep.
Yeah, Human with Colin Nokia. I can't believe I'm agreeing with Torles for once. But all right, I'll put this in my calendar. I think with the ACK aggregation, I agree with him. It is application, so we might have to put that on the side and try to actually understand what multicast will bring into the picture for the ACK aggregation. If you put that into the side, then I think the picture becomes a little bit more. Honestly, I cannot understand what they mean by ACK aggregation. Like, I would imagine each one of those GPUs would reply at a different time. So if you want to aggregate it, there is a bunch of buffering and everything that you need to put in there. So I would imagine that would make everything much, much slower if you go to a huge scale. So I think there's a lot to understand there. So we might have a complexity that we just want to put it to the side for now and concentrate on from the LLM server to the GPUs to figure that part out. That's all. Thanks.
Yeah, that's a good comment.
Great.
Thank you. Yeah.
I got one more. Yeah.
Okay, Jeffrey Zhang, HPE. Beer extensions to address these problems. I actually have some good thoughts that I was not ready to present in this IETF meeting. I should have something to share for the next one. All those related gaps out there, I think I have some thoughts on that. So it's good. I think we can do some good beer work in its current architecture without too big changes in the beer architecture.
Okay. Thank you. All right. We need to move on. All right. How are you? And we'll just need to kind of keep it a little brief. That one a little bit longer.
Good morning, everyone. This is Hao Song from FutureWay. This talk is kind of related to the previous talk Mike just gave. As he said, point-to-multipoint pattern is a dominant pattern in AI networking. We need to also realize the reverse multi-point-to-point pattern is always come in hand with a point-to-multipoint. There are several use cases to prove this. We all know that collective communication is a key bottleneck for large-scale AI training and inference in data centers. Some of them involve like all reduce, MOE, dispatch and combine, and the reliable multicast that we just discussed, or involve the in-network aggregation process, which engages switch to aggregate data in flight. It has many benefits like reduce the traffic, reduce packet latency, and also free the host cycles. And logically, it forms an overlay tree on DC fabric. You can observe it's exactly in the opposite direction of the multicast tree. They can have a different shape, but they share this common root and the common set of leaves. So this draft, we will provide a forwarding layer framework, which uses unified encoding for both trees. We have 3 first-class use cases, or reduce, MOE, and reliable multicast. So this slide shows a figure. So we can see the from up direction as aggregation, and the reverse direction is a multicast. So we can use a encode, give each node, worker node, an index. Therefore, we can represent the worker set as a bitmap. If it's in the really sparse mode, we can just list their index as a set. So since every point can get index, so we can efficiently to implement the aggregation tree from the leaf to root, and the multicast tree from the root to leaf. So to represent aggregation tree, we simply need to configure each node, which is a switch in the network fabric, to tell them which set of workers you should aggregate. And of course, each packet will carry a header to tell, okay, what's a worker ID, and when it's aggregated, the header will be updated to tell currently what has been already aggregated, and continued work up to the tree until it reaches the root. All the things has been done there. So reversely, the multicast tree, we can see it's very similar to the principle of the beer. We can just simply use a beer-like stateless forwarding. So the two opposite directions can use the same set of encoding method, although they can have the different shape. So the benefit of this unified encoding is, first off, it's very compact. We can use a simple node list or the simple bitmap to do that. We can support stateless multicast. And for the aggregation tree, it's self-describing. And also it's topology independent, because now we only encode the endpoint. So it's regardless what's the tree shape of the topology, physical topology is look like, it can change. It doesn't change the endpoint node set. And if we use a bitmap encoding, it's hardware friendly, because we only use simple logical operations to do the to decode the header and perform the aggregation or multicast. And it supports the highly dynamic scenario. It allows a single package to use a single different tree, so it's very flexible. And also it's a direction agnostic to allow us to use one tree to drive both directions. So why not beer? As we see, actually, at least for the multicast direction, we can adopt beer's bit position encoding and reuse a similar replication behavior. But beer itself cannot realize framework. First reason is that we have a direction here. We have aggregation direction and the reverse multicast direction. So at least we use the same encoding, but we need at least some information to tell what should we do is for do aggregation or do multicast. And also for the AI particular job, we need to distinguish the different job or different tenant ID. And also for the flow packet, maybe each packet will take a different tree. Then we need, in order for the correct aggregation, we need to have something like sequence number. And also for the scalability, we can have support different type of header encoding style, like either bitmap in the dense mode or the node list in the sparse mode. So that means we need to support different encoding style, than which beer right now cannot support. So here, some thought about how we support a really huge multicast tree or aggregation tree in a different mode, like a dense mode or sparse mode. For a very large possible set of leaves, we can have two methods to make it scale. First, we can horizontally partition the tree. So we can have the hierarchical bitmap For example, at each pod level, we have a pod level bitmap, but when it go up, we can summarize all of this into a single bit to the upper level. It's very naturally to fit in the data center topology, and can reduce the header overhead to the most extent. And we can also do the vertical partition to partition the topology into a multiple separate parallel trees. So each tree can have a much smaller bitmap to encode the leaf nodes. And in another use case like the MOE, usually for each multicast or aggregation, we call it a dispatch and combine. It only involves a very small number of workers, but the total possible set could be large. So in this case, if we still use a bitmap, it can be very inefficient. So therefore, we can just use a node list to just put their index in the list to encode the set of workers, active workers. But by doing this, we can still follow in the similar forwarding behavior. There's nothing changed, but it's just different encoding process. So as a trade-off, we can, in a single node, we can support a flat bitmap, hierarchical bitmap, or node list. We can even combine all of these three in a single solution. It's very flexible. So the status of draft is in this draft, we just provide this framework and the 3 first-class use cases and give the gap analysis, some analysis on scale and encoding, and some security considerations. So for the group, I'd like to ask the audience to consider, is this encoding framework a useful basis for in-network aggregation standardization? And maybe consider the preferred home for this. Should we consider to extend beer, or some new encapsulation protocol should be defined? And also we'd like to see the interesting review and the collaborations, and anybody would like to work with us, please talk to me. And of course, any feedback I'm welcome on the list. Thank you very much.
Tony P, HP Juniper. So for reasons unknown to God and man, you're not presenting in beer, so I've shown up here. It's a mixture between misunderstanding how beer works and reinventing. So the direction is actually, I think you are misguiding your understanding of beer. If you set the bit towards the root, you will naturally get the other direction. Beer is bidirectional by nature. It's actually a PIM-C, which is inclusive and selective at the same time, and bidirectional.
It's used for multicast, right? Here, I mean,
but you
for
can
aggregation
send from any
network
source to any set of destinations.
Yes.
There is no direction. So you can send down, and then if a guy sets just the receiver bit to back, that the thing will go back on the same tree.
Oh, yes, but still the semantics is to...
There is no semantics of direction in beer. Beer is a PIM-C, which is selective and inclusive and bidirectional. I know it's confusing. All right, so you don't need a sense of direction. The other things that you said, like
No. I mean the direction here means the semantics for aggregation or for multicast. It's 2 different operations.
Yeah, but that's what you put inside the frame.
The node has to distinguish these
well,
two
the
cases.
root doesn't say X. So if you see an ACK, you aggregate, right? So the ACK tells you semantically that's what you aggregate, and the other stuff you multicast to everyone. Right? And you can even go and look at the ACK, because the ACK has a single bit that it sets. So you can just look at the beer head and say 1 bit set, it must be an ACK. Otherwise, you do something funny. So I think that's like a major understanding how the beer application thing works. The sparse set is an interesting discussion. There is already something in beer, which you probably didn't see, which is called ubeer, which is under discussion, hanging there. Okay. So if you're interested in that, it does literally that. This lock bit mask is an interesting proposal. Don't know. Yes, log 2 n bits. Yeah, so the node list is already proposed, right? The hierarchical bitmap is an interesting problem. I don't know how you want it to work.
Which one?
The hierarchical bitmap is an interesting proposal. I would like to see the details how that's supposed to work, because once things get big, you get into sets. So this thing, yeah, you could do a new thing if the group is really small, really stable. You could do clever stuff.
Yeah.
But if you start to go and move towards solving basically the large number of receivers, few trees, then you're basically reinventing beer with a sparse set. The hierarchical thing is the only interesting new thing that I'm seeing. All the rest, like I said, is either already been done in beer, or otherwise there's a misunderstanding how beer works. And the things that you pointed out, I think the previous set, which was that you need transaction ID or something. Sorry, the previous one doesn't flip. Right, so the job tenant ID, sequence number, that's the thing that go basically carried within the multicast. I don't think you really want to stash it into the header, because then you basically build an application-specific multicast, right? Beer originally was supposed only to work for L3VPN, EVPN, and encode all the identifiers right there, which we threw out, right?
Yeah, so because we want to combine the in-network aggregation and the multicast, so many of these requirements actually come with
which I
in-network
think
aggregation.
It's a really poor idea. You can smash all the layers together and have one single bit meaning everything, and it ends up in tiers, because you're basically building a failure domain where one thing brings everything down. But
yeah,
you know,
media has already realized in-network aggregation many years ago.
I know how Sharp works.
Yeah,
I know how Sharp
that's
works.
not a new idea, and we just now want to combine this with a more efficient encoding to support both.
But for example, something like smashing Sharp into a single header with the multicast with the beer, I think is just a poor idea, but you'll find out. Okay, so like I said, most of the stuff has already been done in beer. The hierarchical thing is interesting, and the direction, I think we have to talk how beer really works, because it's basically already inherent in the switching metric that beer is. Thanks.
Just a couple more minutes. We got to get going. We got one more presentation.
Jeffrey Zhang, HP Juniper. Can you go to the next slide? Yeah, I just want to add to what Tony said. Pretty much, if I understand this correctly, all these things on these slides, beer can already do, or we have already extension proposed. For example, multiple parallel trees. I believe it's basically means the multiple sets in beer. Maybe not. That's not the case. We can talk more offline. Hierarchical bitmap, maybe it's just a segmentation. For example, you have a large domain, you separate it into different smaller domains, and every border, the border routers become a BFER, and so you basically domain to domain. Maybe that's not what you mean, but we can talk offline. But if that's what you mean, it's already supported. And sparse sets, node list, as Tony said, is already been proposed. We have not pushed it forward yet. And then another thing is that when you are using it in the MOE environments, and most likely the source GPU, source server, can choose a set of experts that are in the same cluster, so that even you do not even need to use the node list. You just, when you have if they are together, most likely you can just use one set to send traffic there. So we can follow up offline, but I believe all these things can be done already in beer. Thanks.
Yeah, so the sparse sets and the hierarchical bitmap, that is pretty much exactly what we implemented with RBS, on which is the first draft in 2022. In the meantime, when the professors looked at it, we also came up with the combined, hierarchical bit sets and or list of receiver identifiers, right? And that's all based on you're representing the tree through which it goes through the network. There have also been kind of almost as early as beer itself been proposals to have these hierarchical bit strings explicitly for well-known data center topologies from research organizations, right? So they don't adopt themselves nicely to arbitrary topologies, but if something needs to be optimized for one particular kind of we built a couple hundred of billions of dollars with the same data center type. Those are optimizations that have already been defined, right? So I think all these things are well known. The hard work is really just to figure out what exactly are the use case requirements. Can we do it with, any of the tricks in beer? If not, then we have the proof point of do something better, and then we have a rich, set of pre-existing things. So we don't need, any more groundbreaking new ideas. Those have already been theoretically and in, prototypes been done. It's now the hard work to figure out matching, the business cases with the solution framework.
Thank you. I appreciate it. Yeah. You got your 15 minutes.
I asked for 30 minutes, got 15 minutes. I'm going to speak with double speed.
Put the microphone a little closer to you. Yeah.
So, all right. Few things which we are going to talk about is mostly with respect to PIM. How can we simplify it further for operators? So now I think most of the time we think as engineer, we come up with a very complex solution. I'm trying to see that can we look it from the other side? Who is the actual user of the PIM? So there are three ideas, or rather three problem statements, which I'm going to talk about. And the reason why I have not put any solution, because I have some solution in mind, but I want to hear from others as well, so that we can come up with something which is really useful for operators. The first one which I'm going to talk about is source discovery. ASM has been a pain for everyone for last many years. And you talk to any customers, operators, even vendors, everyone does agree that there is a problem. All the state machine which has been defined in PIM protocol, it is pretty complex. So when I say complex, it is mostly related to when you have to debug something. When you have to, as an operator, if you don't really understand complete PIM state machine, it becomes very painful to see where exactly traffic is going. We did work in this area. We came up with PFMSD, which was developed in same working group. We have implementation, but it has challenge with respect to scaling. So if you have large network and if you keep flooding your source information continuously in the whole domain, that is not something really customers or operators are expecting to happen. The second thing is, if you don't have PFMSD, then you have to live with RP. To have RP, you have multiple protocols, whether it is static RP or bunch of dynamic RP protocols. Then if you have multiple domains, you have to run MSDP between them. So with PIM, actually we are adding 5 more protocols on top. That makes overall experience very hard. And when we are migrating to IPv6 based backbone and coming up with PIM based solution, again, these problem statements will continue. So I started thinking about it, that how can we get rid of this whole RP business in the backbone? We cannot get rid of ASM, and the reason is very simple, that there are millions of set-top boxes which can do only star G join today, and none of the operator will bear the cost. Me as an end user, I'm not going to update my set-top box because my operator wants to do IGMP v3. So that is not possible. So we'll have to solve it in the backbone. One of the probable solution I was thinking of is coming up with something lightweight, similar to the route reflector. And I was talking to Jeffrey. Thanks, Jeffrey, for comment that maybe we should consider using BGP itself rather than coming up with something new, because BGP has been well-defined protocol and it already knows how to scale hierarchy. You have to do if hierarchy, if you have multiple RRs, how they talk to each other. There is a well-defined process. So maybe it will be worth considering that can we announce source using BGP itself. So there is no more shared tree. You directly learn about all the sources. You do direct SG join. That is one of the problem statement. Though if we had whole 30 minutes, we could have spoken for long. Do you want me to cover all and then ask question? I see you in queue.
So you're saying just use BGP to announce information for SSL mapping.
Kind of, yes. We'll go to second problem statement, which is MOFRR. So today, 7431 defines the base MOFRR, and I think all of us, majority of the vendors have implemented it, and it is being used as well in the field. There are two types of MOFRR which is possible today. One is RIP based and second one is flow based. So let's understand what happens in flow based MOFRR. In the last half router, if you have network something like this, in the last hop router you can have some kind of monitoring here where you are really monitoring both flows from the not red, blue and green path, and you are accepting one of the traffic. If there is a failure happening anywhere in the network, you will be able to detect it fast enough, and once you detect it, you immediately do this RPF switchover. Life is very simple from outside, but implementing this, it's very hard. So when I say implementing this very hard, what it means that ASIC really takes a toll. So if you start watching or monitoring each flows, something else has to be dropped off. So basically the load on ASIC becomes very extensive, so it becomes a costly solution. The second one, which is used mostly, is RIP based. So in case of RIP based, from last hop router, I have two next hop. It could be ECMP or UCMP. And when I start sending the join, I may join the primary path and backup path. And once we start getting the traffic, you will have, based on some logic, it could be any hashing or it could be priority. You accept one of the path traffic, and the second one you start dropping it. So you have to really detect that something failed before you can move to the backup path. So let's see what different type of failures are possible and how we react today. So if there is a failure here, LHR can immediately get to know that there is a failure and it can switch the RPF. Life is simple, fast enough. You won't see the glitch. What happens if traffic, this link fails, which is FHR to P1? Again, same thing. LHR will be able to detect the RIB next hop change. And right now, even though I have made as a blue and green path, don't consider it as a flex algo. You can consider it as a still two path. So the RIB next hop changes, I will be able to switch to the next path immediately. But what will happen if if failure is between P1 and P2? So in case of P1 and P2 failure, for LHR, there is no next hop change. LHR is still pointing to P3. P3 is going to take care of the local repair. So your PIM join will take care of going to the different path locally. What this result into that you will have a traffic loss in the receiver. So receiver sees the traffic loss. Last hop router has both copy, but still it cannot do anything. So this is the problem statement which I am trying to talk
sorry,
about.
it's human. Just for everybody to understand, today there is a solution for that. It's not optimized, but there is a solution for that because P1 sends the traffic active to P2, but then there's going to be a backup traffic to P4 to P3 where P3 drops it, right? But what you're kind of saying is that that's sending traffic to every single link and it's congesting the network. You're trying to optimize that.
That's correct.
Okay, yeah, just to make sure.
Yeah, that was my next statement anyway, I was coming to. So today, the way we solve this is you turn on MOFRR everywhere. So if your network is large enough, every hop you'll have to create two joins. So depending on how many hops you have from receiver to source, that many copies of the traffic will be flooded across the network. So what we are trying to do, that can we do some more simplification here, or is there any way to really optimize this overall solution? One of the solution which is in mind, and right now it is not updated in the draft. Let's say that what exactly we are trying to achieve. We are trying to achieve two things. In the last hop router, I should be able to detect the failure anywhere in the network. The second part I want to do is I should be able to understand that this network failure has impact on my what all trees, tree 1, 2, 3, whichever trees. And then based on these two parameters, I want to make a decision. So one of the solution which comes into the mind is detecting the failure. Today, IGP already distributes your link state. So any change in the link state, we already know. Last hop router does get the notification. So we have that information already in the last hop router. So one part is solved. We have this information. The second part is, how will I know whether this particular failure really is going to impact any of my tree? And this is where we need some kind of modification. Again, not keeping as a engineer's eye, rather I'm thinking as an operator. I don't want to overload PIM protocol to give me this info that where exactly my tree is going from. And one of the probable solution which we were thinking of, or I was thinking of, is can we use telemetry, where today telemetry anyway exports huge amount of or many vendors, they have implementation where you can export your SG info, that each tree is going from where, which link and which router. And if we are able to also export the IGP unique ID associated with the link along with SG, somewhere it could be in the LHR directly, or it could be some external, you can consider at a controller is the wrong word, but external processing center, where we are able to get the whole tree view. Then last half router can really merge both of them together and take the action. Tony.
So it sound like Ross White. So it's the epistemology gets in the way. Okay, what does it mean really? What makes you think that any mechanism, when you're looking a couple hops away, will be faster than the 50 millisecond local repair there? See whether it's so let's say you start on the LHR to look at the P4, you can using some network telemetry.
Mhm.
Okay, if the so let's no, if the P3 creeps out, you're totally done. But let's say the P4 telemetry path goes some way and something in the middle fails, right? Which has impact on your multicast tree, but the telemetry also has to reroute around it. And that needs time. And the farther you look back, right, whether you use telemetry, what makes you think IGP flooding will be faster than local per 50 millisecond before IGP coughs up all this stuff and then coughs up the SPF, and then you'll be probably at the same point. The problem is that you want to look far ahead, but you need some time to diffuse the information, unless you entangle the bloody things, but then it's a different working group, right? If you don't have entanglement, all these things have delay in propagation. There is some kind of, diffusion front. And there is no magic to shorten this diffusion front, right? So I don't think there is much you can do here from the very foundation of the problem, but, tell me.
Mm-hmm.
So I remember this discussion from 2008 with Comcast, right? So it's kind of totally annoying that seemingly none of the vendors has managed to do, packet reception based MOFR failover as opposed to control plane based failover, right? And so I mean that was the whole point of doing MOFR in the first place, that we can do traffic absence based failovers. There are also products that do this, seemingly not any of the core routers, right? I remember several of the video products that are supporting that. So if I may be very self-serving, I would say that it's perfectly fine that vendors that have these type of products suffer the pain. And if you want to see a better solution, I'm recommending to listen to BRFR in the afternoon, right? So because that provides a perfectly well working sub 50 millisecond solution failover.
So Nils Warnke, Deutsche Telekom. These failover scenarios to me are very real because we experience them, and we have a lot of pain in the past, and this 50 millisecond failover promises have rarely been kept, let's put it this way. What I can spill is that as soon as you are above 150 milliseconds failover, you experience some issues in the picture with TV products. As soon as you're above 300 or 250 milliseconds, you experience a still picture or an error picture. So these fast detections to us is really a key issue and a key thing that we're looking for. What I've seen is especially RIP tends to be rather slow. So any optimization we can find there is really appreciated. From a flow-based approach, we've looked at this, and this is something that we've really grasped for since long. But knowing larger deployments and how heavy this is on the NPUs and the hardware inside the routers, this has not really been something that scales. So I'm really curious on what we can optimize there. I'm not quite sure, but if we can leverage messages inside the routing protocol, for example, where we can either up the tree or down the tree message these kind of failures and give an indicator to fail over quickly, that been a discussion that we've been having a couple of times as well. But honestly speaking, not being an expert in these route messaging advertisements, I can't really judge if this is an option that's feasible for looking into.
Sure.
Sunny Zhang, ZTE. In our implementation, we borrowed some method from BFD detection for the failure fast detection, and we do some special execution on the remote detection, such as P1 can report some key failure events to LHR, so LHR can change the way quickly. So I think, in my opinion, it's an interesting topic, and we can talk it together and to help to it better. Yes.
Sure. So I'll answer the Tony's question first.
And then we got to kind of wrap it up.
Yeah.
I'm sorry.
BFD.
Yeah. So about your question I got your point. So I'm answering Tony's question, where the 50 millisecond local repair for PIM, if there is a failure between P1 and P2, P3 has to do a bunch of things. First, detect it. Second, do the RPF change. Third, program the hardware, right? And then you send a join via this path. Depending on how long this path is, in this picture, it is very simple, just one hop away. But it could be multi-hop. The time you cannot guarantee that it will really recover in 50 milliseconds. So that is number one. The second thing, telemetry is just one time in advance to understand the tree. Telemetry is not being used for all the signaling. The signaling, what I'm using is your update from the IGP. So IGP update, which you are flooding, definitely it is going to reach much faster. I won't make it a generic statement, but in the high scale, yes, it will be much faster for LHR to understand that that link failed compared to this whole processing happening in these core routers.
With the PIM signaling. Okay,
Yes.
Yeah, I can. I agree.
And about BFD, BFD is definitely one of the choice, but per tree you have to maintain a BFD and then act on that. Yes, so it is not going to scale. And thank you.
Thank you for your time. Sorry you didn't get it.
no
more. Yeah.
You got one more presentation.
Yeah, I know.
But you want to
Yeah, we don't have. Yeah, sorry. Thank you. Next time.
All right. Do you want to?
Yeah, thank you so much for your time. We'll continue. A lot of this on the list. Let's go.
I kind of wonder if this point-to-multipoint BFD might help in a way. I think it's like one BFD session for the whole tree or something.
I don't know, but I wish we had more time on that. That would have been better.
Yeah, it's some interesting discussion.
Yeah.
I know we usually end up having too many presentations and no discussion.